So we're going to continue talking about interesting methods that are part of the observable class. And of course, as always, we'll also take a look at the source code that implements these things. So let's go ahead and take a look here. We're going to talk about a couple of new methods. We're going to talk about the generate method, and you'll get a chance to see how generate can be used. So this is a test method called test fraction multiplications 1, and it's in the observable ex.java file in my ex3 example. And it's again going to basically perform reductions and multiplications of the results. And we're going to look here at the use of generate, and we're going to take a look at the use of collect. So these are two methods we haven't looked at before. We looked at other variants of those methods before. So the generate method is going to return a cold, synchronous, and stateless generator of values. And what happens here is you pass in a callable, as you can see here, and that callable is then going to be called in a loop after the downstream observer has subscribed. And it's going to just keep generating until either it emits a complete, or if you use the take method, as we're going to do here, you can tell it to stop. And what the callback does is it should call on next whenever it wants to emit something, or on error or on complete to indicate that something is finished. A new observable instance is returned, and that, of course, will be fed down the chain to things down the pipeline. So unlike the create method we looked at before, which can be used, as we'll see in a moment, to generate sort of an infinite number of things as quickly as possible, the generate method only generates one event at a time. And that allows support for something called back pressure, which means you can prevent a fast publisher from sending data more rapidly than slower subscribers can process. So in contrast, the create method that we've talked about before will just generate events whenever it feels like it, and it doesn't take into account any back pressure. So you can end up overwhelming the amount of processing that's going on there. So create, which we looked at before, is sort of a variant of generate. There's also a generate method that's part of Project Reactor's Flux class, and the stream class, the stream framework, also has a generate method that does pretty much the same thing that generate does here in RxJava. Then we also have the collect method, which collects items emitted by some source observable into a single mutable data structure. This should look very familiar to you now that you know streams. The first parameter that's passed into collect is a mutable data structure that accumulates or collects the items. So as this shown in this example, we can do things like collect into an array list. And then the second parameter is a by consumer that accepts the accumulator and the emitted item, and then updates or modifies the accumulator by basically adding it to that accumulator. What you get back from collect is a single that will emit whatever the accumulator has been accumulating as the result of doing collect. You can think of collect as basically a simplified version of reduce that doesn't need to return the state on each pass. So it doesn't have to basically keep passing the state back in each time. It just accumulates it into this accumulator, which is the first parameter. Project Reactor has a Flux collect method that works essentially the same way. And there's also something called Flux collect list that does something very similar as well. And you could also think of collect as being very similar to collect into, which is another variant that is provided in RxJava. And of course, the collect method is very similar to what you see with Java Streams. Although Java Streams has this data structure called a collector that encapsulates some of the logic that is otherwise kind of handled by the parameters that are passed to collect in RxJava. Okay, so with that in mind, let's now go ahead and take a look at the source code for this example, and you can see all the pieces fit together in a more comprehensive way. So here's the test fraction multiplications 1 method, which uses an observable stream and a pool of threads to perform BigFraction reductions and multiplications. We will now look at the methods we've talked about, such as collect and generate. And of course, we'll also leverage other methods we've seen earlier, like take and so on. So first thing we're going to do here is we're going to define ourselves a consumer, which is going to essentially encapsulate an emitter. And so what'll happen here is whenever this consumer is called, it'll go ahead and cause the emit parameter to emit the next item. And you can see what we're going to emit will just be some random, non-reduced big fraction. So the emitter is just going to emit these things. And it's going to emit them in perpetuity. It never stops emitting. So here was how it looks. We say observable.generate, passing in the emitter consumer. That'll start emitting things. But because we don't want to emit in perpetuity, we don't want to emit forever, we're going to go ahead and use the take method here to only emit S max fraction items, which is set, I believe, to 10. So we're going to emit 10 items. And then what we do is we're going to use the flat map method. And this is going to use the flat map concurrency idiom, which we'll look at here. And then we'll look at it more carefully in the next example. And what that does is for each unreduced fraction that was emitted by the generator, we're going to call a method called reduce and multiply fraction. And that's actually what's going to do the heavy lifting for the flat map concurrency idiom. And we'll look at that method in a second. So that'll go ahead and do the computation. We're going to end up then collecting the results into an array list. And we're going to add each new element at the end of that array list. So you can see here we pass in a constructor reference to an array list of big fractions. Collect is going to add an element to each one. And so what we're going to end up with when we're all is said and done here is we're going to end up with a single to an array list that contains all the reduced and multiplied big fractions. And then what we do is we go ahead and use flat map completable in order to essentially sort and print the list. So here's the piece I want to talk about. This is called reduce and multiply fraction. So for each unreduced fraction, this method is going to be called. And here's what it does. It's going to go ahead and take the unreduced fraction that's passed in, and it's going to use the from callable method in order to be able to reduce this unreduced fraction in, it's going to go ahead and reduce the unreduced fraction. And it's going to do this in the background thread that's provided here, which is the scheduler that we're passing in. And so as a result, this processing is going to take place in the background thread. And then we're going to go ahead and use the flat map idiom again. And for each element here, we're going to go ahead and multiply the fraction. And again, we're going to do that in the background thread. And you'll notice that we're using a from callable to do this. And I'll talk a bit more about that when we talk about the next example as well. Okay, so that's basically the code that we're going to use to do this processing. And if we run this code, then you should see the results that we get. So it's off cranking away. And you can see here that this is the results of test fraction multiplications 1. So we ended up with printing the sorted results from a bunch of randomly generated big fractions. And you'll notice that test fractions multiplication 1 actually finishes after test fraction multiplications 2. And we're going to look at test fraction multiplications 2 in just a moment. But the reason for this is that this computation took longer to run. And because the whole thing is running asynchronously and we're using the async tester framework, that works perfectly well. So that'll print things out as they finish.